Now we're getting to the second thematic session of the day and the last for this morning. And we welcome the moderator, Angelos Bekiaris. He's the director of the Center for Research and Technology in Greece, CERTH. And Angelos will be handling a very impressive lineup of speakers. I'm really looking forward to these presentations. We're talking here about unleashing the potential of digitalization. Angelos, your video and mic open, and the floor is yours.
Thank you very much. Really, we have a dream team here. Thank you for bringing all these super experts. And as time is pressing, we start right ahead, Susanna. So we start with Dr. Clarissa, that she's an international leader on sustainability and resilience in the Australian Road Research Board. And her presentation will be on infrastructure, digitalization, and mobility future. Clarissa, the floor is yours.
Thanks, everyone. I'm just trying to share my screen. I think now I'm able to do that. Is that coming up?
Yes, now we can see it.
Great. Thanks, Chairman. I'm Clarissa. I'm from the Australia Road Research Board. I'm the national leader of sustainability and resilience. Very glad to utilize this 10-minute slot to share some of Australia's latest research and progress in the area of infrastructure, digitalization, and integrated mobility future. Australia Road Research Board was set up 60 years ago by Australia and New Zealand federal state road agencies collaboratively aimed to set up a centralized repository of independent transport knowledge. Over the past 6 decades, our mission and vision have evolved significantly. Today, we have a strong focus on sustainability, connectivity, integrated mobility future, and of course, innovation. So I will share a few aspects from big data to the digital infrastructure to the infrastructure readiness in order to support the future CAF operations. Starting from data, we dedicated and committed to work with data from the national perspective. We set up a National Transport Performance Center in order to measure, benchmark, and monitor the road network performance across the board. So this is our first national crash map. You know that our state data doesn't really publish. And the crash data was coded and registered in different systems very differently. Enormous effort was made to create such a consistent reporting structure. So that covers last 5 years fatalities and serious injury. The next map is the traffic data covering the speed and volume data. Our capability to access the national database enable us to realize the road network level intelligence. One more map shows the the road conditions. The data came from our infrastructure measurement group, where we maintain a fleet of network survey vehicles that we connect and collected the road conditions data like the strengths, the cracking, rutting, and roughness and frictions. But all of these data systems doesn't operate in silos. The real power comes when we start to incorporate, integrate, and combine this data together. So I'd like to show you an example. In order to illustrate this, we have created a new set of performance indicators. Such as a driver's frustration. We not only consider the measured congestion by speed and delay, we also take into considerations the road conditions, the road space that is available to our drivers in order to measure the driver's frustration. Look at this map. This is a typical weekday PM peak. The driver's frustration along our Melbourne freeways is indicated on this color-coded map. I'd like to emphasize our next wave of data came from the connected vehicles or vehicle-enabled data. This is another example I'd like to mention, that we were able to utilize the data coming from the HERE technology map. Here is our research partner. So this technology map was made available to many connected devices, such as vehicles, watches, or smartphones. So the data came from these devices covers a wide range of information, not only the speed and location, but also many information from vehicle sensors like the wipers, the hazard lights, and radar. We were able to incorporate this data and create a hybrid model and data fusion to be able to fill in many gaps of our congestion and reliability assessment. There's still a lot of potential to further utilize this data to fill in the gaps of a road conditions map. As Australia New Zealand National Transport Research Organization, we constantly investigate or monitor the technology trend. So the investigation has confirmed that the cloud connected vehicles are coming. Our vehicle OEMs are providing increasing level of data connectivities. Per our investigation, as shown in Oslo's Future Vehicle 2030 report, it is envisaged that by 2030, majority of the vehicles sold in Australian market will have certain level of data connectivity. At the same time, with the global growth of the 5G subscriptions, it is also expected that more than 50% of the mobile phone traffic will be carried by the 5G network by 2026. All of this enable great potential opportunities for our road agencies, public sectors, and industry bodies to create cloud-enabled connectivity. Of course, there are many challenges, such as data exchange protocols and standards, cost-benefit identification and assessment, and also the service level commitment and arrangement. But we have to be prepared. ADV. So the Driverless Vehicle Initiative was founded and initiated by ARRB since 2015. Since September 2015, our Australian and New Zealand road agencies started to conduct all sorts of AV and CAV trials across our road network. Our ADV is a public-private collaborator or consortium. By now, we have more than 150 partners covering 3 sectors: the government agencies and regulators, the industry technology providers, and of course, the public consumers. The mission of our ADV is to safely accelerate the adoption of driverless vehicles in Australia and New Zealand. Another news is we have just concluded our 2 days ADV Summit 2021 yesterday. Do check our website to find the latest, please. On top of that, we also conducted a lot of work in order to measure our infrastructure readiness to enable the future automated, fully automated or partially automated driving operations along our road network. This map shows we have about 98,000 kilometers of freeways and highways in Australia. And we have conducted a enormous road audit in 2019, which covers about 25,000 kilometers of our freeways and highways. That is equivalent to 90,000 map links, 8.4 million line segments, and also covering 8,500 road signs. Our server vehicles equipped with the latest module of machine vision cameras, which is just the same as whatever available on the market with ADV or ADS. And the driving tasks covering the selected, even distributed freeways of both regional and rural areas across have coverage of all the Australian states and New Zealand. So the key attributes we look at for this survey covering both the digital infrastructure and physical infrastructure readiness. The audit or assess result can be illustrated using this map. For different type of infrastructure element, we were able to comment on the confidence levels at different segments or links of the roads, like high, medium, and low. our infrastructure is also assessed in a comprehensive way in terms of highly likely to be suitable, may be suitable, or unlikely to be suitable for selected, assisted, and automated driving functions. We were also able to provide a large list of recommendations or comments on the current readiness of infrastructures and of advice on the infrastructure change requirements and standards that will enable the future automated drivings. Before I conclude my short talk today, I'd like to quote an architecture model that was proposed by my ARRB colleague, Dr. Charles Kao, on a architecture layer or 6-layer models from bottom to the top, covering the necessary system network or system network elements that will be integrated.
Clarissa, sorry, excuse me. Maybe you should conclude because of the time pressure, if possible.
No worries.
Thank you very much. And sorry.
Thanks, everyone.
No, you can still have your conclusions. You can still have your conclusions if you like. 1 minute,
okay,
if you want. Yeah.
Oh, thank you. Then I just briefly introduce this little model, 6 layers from the physical infrastructure at the bottom, covering our roads and device. Then the digital infrastructure cover the cloud connectivity, Wi-Fi, and emerging technologies. Data is sitting on top of that, covering from different sources. Logical element is the safety, operational, and regulatory element that would support a safe and efficient operation of this ecosystem. Processing and services are sitting on the top to provide these seamless services to different road users. So our future mobility will benefit significantly when the services are integrated, and all the services will critically rely on the cloud connected data in the near future. So this is what we call the Australia Pantry. That's it. And stay connected with us via the social media or the website. And thanks everyone for your time. Thanks, Chairman.
Thanks, Clarissa. I'm personally very impressed. You seem to have the AISCAT quite ready across Australia for CAV, and you are calculating CAV readiness. I think you are at least 1 step ahead of Europe, maybe more, but really impressed. If there is any important question, we could go to that. Otherwise, because we are delayed, we can move on. But I don't see any hand, so I hope that we can go on. I will come back to you because personally, as I said, there are many lessons that we in Europe can learn from what you're doing. Thank you very much.
Thank you.
We move to the next speaker, who is Federico Di Gennaro, the head of strategic projects, Omicron project AISCAT Servizi, and he's going to talk to us about Omicron project and especially boosting the automation of infrastructure maintenance. Very interesting, automation in infrastructure maintenance. So Federico, the floor is yours.
Thank you, Chairman. Thank you to all of you. I'm gonna share my presentation here. Can you see it?
Yes.
Yes, we can.
Okay, thanks. So, ladies and gentlemen, good morning and good evening to all of you. I'm honored to have been invited to speak at this very important event for IRF and for the entire road transport community. Even if we are not in person, I'm glad to see a lot of colleagues and friends among the attendees, and I hope to shake your hands and have a dinner together very soon. In my presentation today, I will try to give you some interesting information on how to improve road maintenance procedure thanks to new technologies and solutions. I'm pleased to introduce you the Omicron project, going step by step, discussing the main concept, the main solution that will be developed and tested, and where and how we will validate the Omicron full solution. As you can see, Omicron is a project funded by the European Commission within the Horizon 2020 program. There are 16 partners from 7 countries for an overall budget of 5 million euros, 100% funded. The project started in May this year, and it will last for 32 months till October 2024. Semosa, which is a Spanish engineering consultancy company, is the coordinator of the project. AISCAT is involved as co-coordinator of the Italian demo site together with the Strade Parchi motorway company. The objective of the Omicron project is to develop an intelligent asset management platform specifically designed for road infrastructure, which will improve the whole asset management pipeline, focusing on 4 main pillars. The first pillar is composed by a set of solutions to improve the digital inspection activity, taking advantage of the combination of drones, terrestrial vehicle for inspection, integrating also real-time information coming from V2X communication in road maintenance. The second pillar will be made by the design and integration of a road digital twin using information coming from digital inspection data as well as from other sources, ensuring the capability to use information from legacy system and to guarantee the interoperability with existing tools. The third pillar is the design of a maintenance decision support tool for roads, using the information coming from the digital twin. Omicron's intelligent platform tools will be integrated to support the decision-making process of infrastructure managers and operators. The fourth pillar, is made by the design of a multi-purpose modular robotic platform, covering key emergency, ordinary, and extraordinary intervention actions, improving the safety of workers and enhancing the training capability. Going more into details, we would like to further implement the cooperation among different long-range UAVs for inspection, allowing different drones with different roles, close views, long-range views, communication relay in the inspection, by including different sensors and communication system. Regarding the inspection vehicle, we will develop a ground vehicle inspection solution to collect a great variety of information through images and to process them, such as the computation of the IRI, friction and deflection coefficients in roads using artificial intelligence techniques. Then we will deploy also V2X communication in the field of road maintenance by using standardized CATS services, such as maintenance vehicle approaching, traffic, roadworks, warnings, weather condition, and so on. Another component is the modular platform. Omicron will develop a semi-automated mobile manipulation concept formed by a robotic arm, which operates autonomously, mounted on a standard vehicle, in order to improve the safety and easiness of installation of road signals on both left side and right side of the carriageway. Then a vision system will be developed to identify the presence of signals and estimate the relative position with respect to the robot, and control logic to generate the trajectories and to activate the cleaning tool. Another tool is related to the automated installation and replacement of safety barriers that will be done by the robotic arm, which will take the barriers and place them in the right position, minimizing in this way the risk for workers. Then another tool is made by the removal and painting of horizontal markings, which is a very common and critical task. Omicron will deploy a laser rad for paint removal to be operated with the modular robotic platform, avoiding the reduction in the friction that can result in a risk of slip for vehicles. Then, regarding the sealing of pavement cracks, the current process will be automated by the use of a modular robotic arm, which will be able to operate the pipes of the machine and apply the bitumen over the crack. Then, Omicron will also automate the surface pavement layer rehabilitation activity, providing decision support information along the whole process, in order to improve it and in order to enhance human operator decision, leading to reduction on the overall cost of payment by increasing its useful life. Then we will also develop a web-based virtual reality platform that will be utilized for the teleoperation of the robotic resources from a remote and safe environment. It will allow users to control the navigation of the robotic resources in real time. The development of augmented reality tools will support in-field road workers and will enable an improvement in the management of maintenance works, providing also better information capabilities that will optimize the resources used, ensuring better safety conditions during the intervention. The road asset management platform will integrate all the various technologies developed in Omicron, providing an enhanced control center with a full visualization dashboard for road operators. This will provide a more realistic experience of the state of the infrastructure and the management of the work to be carried out on the road, using multiple information coming from multiple sources. The technologies will be tested in different sites, according to the level of development and in 3 main stages. Stage 1 will test the UAV, the modular solution for bridges, and the robotic platform in a lab scale. Stage 2 will test the solution deployment on a real scale in 3 different sites. A virtual one, which is the overpass of the A3 highway in Portugal. Then the second demonstrator will be on the M30 in Madrid. The demonstrator number 3 and 4 will be respectively the A92 in Spain and the A7 in Spain, part of the Mediterranean CEF corridor. Then the final Omicron platform will be tested and validated in Italy on the A24 highway in the central Italy. Going to the conclusion, innovation without impact is a waste of resources. So the project results will be measured using KPIs related to the impact of the technology for the safety of workers, in the reduction of the traffic disruptions, the routine maintenance cost, and measuring the increase of the network capacity. I would like to close my presentation by remarking the importance of innovation and the added value of introducing new, cost-efficient technologies to improve motorway operational activity. I really hope to be invited again by IRF in a couple of years to share with you the advancement of our very ambitious projects and to enjoy the conference in presence. Thanks to all of you for your kind attention. And for any info, please contact me or the project coordinator from Semosa, Mr. José Solís Hernández. Thank you.
Thank you very much, Federico. You did more than you said. So not only automation, but we have seen augmented reality, virtual reality, a full bouquet of new technologies applied in this in the sector. I think impressive, and indeed we are looking forward to see the results of your pilots. I think that would be very good when you have reached TRL 7 and you have your pilots and you can compare the before and the after. I think extremely good. Is there any specific question?
I see none.
Yes.
I see none, Angelos. I'm monitoring the question answers for you.
Thank you. Thank you, please. So is there any?
No, go ahead.
No,
not
good.
at the moment.
So thank you very much, Federico. We
Thank you.
Move with Estibaliz Barañano. I hope I say it well. Sorry for that. The general manager of ASIMOB company, ASIMOB, who is going to take us from the maintenance part to the road inspection, quite near, but also different. He's going to speak about AI for automated regular road inspections, and we are very happy. The floor is yours, Estibaliz.
Thank you, Angelos. Good morning, good afternoon, or good evening to everyone. Yes, I'm going to talk about how we use artificial intelligence for automating regular road inspections. So these are the inspections that are visual inspections. There's usually a person from the maintenance team driving hundreds of kilometers a day, just checking visually that everything is okay. Now, that's not very efficient because anything this person doesn't see or forgets does not get reported and does not get repaired. So road authorities, if they want to, let me see if I can, if they want to keep a good knowledge of what's going on with awareness, they need to perform thorough detailing inspections that are slow and labor intensive, normally dangerous and fully manual, except for the solution that Federico just presented for Omicron. But even though these inspections are expensive, so they are done every several years and usually only in the main highways. So the secondary road networks or other networks that do not have this kind of resources don't get this kind of care. And there is a need of good maintenance in the roads, especially this secondary road network. that at least in Europe, that's where the vast majority of road fatalities happen. And they don't have these detailed maintenance inspections. So what we from ASIMOB propose is to use new technologies to use automation in a solution to increase the frequency, the frequency of these systematic inspections, so that critical elements of the roads can be monitored daily, weekly, monthly, bi-monthly, however often is needed. And for that, we have designed a flexible process that is affordable and not so labor intensive, that leaves traceable results so that authorities, road operators can keep good track of what's going on and what needs to be repaired. And it's error-free because, of course, artificial intelligence does not get tired, does not forget, and does not get distracted. So our solution is composed of three main parts. First is the data gathering part. We install small, lightweight commercial IoT devices on board fleet vehicles, normally the maintenance fleet vehicles that are going to be driving along the roads that we want to monitor. And these devices will operate autonomously, automatically, gather video and data of the road and send it to the cloud, where our servers will analyze it using our AI, especially designed for road maintenance. We will extract the relevant information and make it available to the road maintenance team in a very intuitive and user-friendly interface at the traffic management center or their offices. So the onboarding installation of our devices is very easy to do. It's an Android, maybe a dashcam, depending on that, an OBD connector, very small, very lightweight. It takes minutes to install them in any type of vehicle, and it's automated. So the driver just needs to press the button, and everything, the data gathering where and when needed, will be done without any intervention from the person who's driving. And the devices will also send automatically the information. So there is no action needed from the driver, no extra work for them. Now, what can we do with it? Well, first of all, we can detect automatically all vertical segments. So we analyze the video that we gather and look for all the traffic signs and that we find. With that, we can automatically create a digital geolocated traffic sign inventory, just driving up and down a road, and we have the traffic sign inventory. After the inventory has been reviewed and approved, we can support the regular inspections, weekly, daily, or however is needed, so that each and every traffic sign can be systematically reviewed as often as needed. We also enable the remote monitoring of roadworks areas, which are dangerous areas that must be signaled in a correct way. So what we produce from each inspection is a map with the traffic signs and very easy to spot the incidences. For every traffic sign, there is information about the last inspection that was performed. Very easy, just a couple of clicks and from the traffic management center, they have access to the video recorded of that traffic sign or the missing traffic sign if it's not visible, and also a panel view, so they can very easily check for minor damages like stickers, graffiti, branches that are starting to cover the traffic sign or the colors, the condition of all the traffic signs. So these are a couple of use cases. The first one is checking the inventory. So inspection, an automated inspection was performed against an inventory, and the two new signals marked in green there appeared, and there were two missing signals marked in red. So just a couple of clicks, and from the traffic management center, they could access video to check that, yeah, the inventory was actually updated in that case. Another use case is roadwork signage. Of course, it doesn't come in the inventory, so it's marked in green for an incident, new traffic sign detected. And just a couple of clicks, and the maintenance manager can go and see how and where those signs are installed to check if it's the correct installation in the right place. Another thing that we can do, we can detect irregularities in the road surface. We are using accelerometers, and we are adding computer vision to that, so that we can detect the cracks, potholes, sunken manholes, and this kind of irregularities, evaluate the effect on the vehicles and the driving comfort, and register the evolution in time. For each irregularity, we provide a map, so with the scale of the impact to the vehicles, details about its pothole, direct access videos, so that a preliminary visual inspection can be done remotely, and also the historic data, so that we enable decision making about where the most urgent renewal works need to be done. These are a couple of use cases, detecting where the cracks are starting to appear, so that they can be detected as early as possible, so that repair works take as less money as possible as well, or registering the evolution of in this case, expansion joint. We work towards the autonomous inspector, so we are completing our functionality with more things. In the next few months, before the end of the year, we will have ready the horizontal signage monitoring. So we evaluate the visibility of lane markings. With that, we will have the complete horizontal and vertical signage monitoring. And it's important to stress here that improving road signage has proven to be the most cost-effective way to reduce the number of accidents in roads, especially secondary roads. So with that, we will have covered all the signage, so that road operators will have information of where to act and what is important to repair or to maintain. We're also developing a project to detect water, ice, and snow on the road, and we will continue with safety barriers and other crucial elements of road safety. We have a modular design, so we have the data collection, data processing, and client interface, as I showed. We can work with images, geolocated images from third parties, and we can integrate our results in existing platforms if needed. So we are very flexible in that. And this is the team. We are senior technical profiles from different brands like technical services, the ITS sector, software development. We have several awards for our innovation, and we proudly have to add the IRF startup label now, which we are super proud of. And we have already done pilots and projects with public authorities and private road maintenance companies. So far only in Spain, because we are a startup, but we hope to expand these works. And that's all from my side. Thank you very much.
Thank you very much, Estibaliz. Indeed, impressive, and an impressive start, also with winning quite many awards. I have some questions, but I think I've seen some interesting ones. Maybe I can be helped by Susanna. There was one that was asking about if you can understand the color or the colorization of the lane. Can you maybe read it?
For the lane markings.
Yes.
I can read it out for you. It's in the chat. So please put your question in the question function, because it's difficult to trace them back. Would ASIMOB remote inspection system be able to characterize the color and retro-reflective performance of traffic signs for day and nighttime performance? That is key. Having a sign in place does not mean it meets the standard.
Okay, as I said, we have a very flexible approach, and we lose accuracy for giving this flexibility. So we do not measure anything. We cannot measure retroreflectivity. You need special material for that. What we evaluate is visibility. Is it visible or not? If our computer vision does not see it, probably a driver will not see it as well. And an ADAS system will have difficulty in seeing it. But we don't provide, so we provide evaluation. Is it visible? Is it not visible? We don't provide measurement. That's we had to this affordability and this flexibility means that we have to give up some accuracy for that.
Very clear. I think it's probably enough for the road operator to know that there is a problem there, and they can measure only in the place of the problems if they want more. It's I think, clear. In the interest of time, I will not take another question here, but you have all the data, and I think there are many things to go deeper, because indeed impressive work. Thank you very much, Estibaliz.
Thanks.
And with that, we move to Monica Olyslagers, hopefully. That is the Global Innovation Manager of IRAP. And very interestingly, we are going to hear how IRAP scheme is using big data for road safety, from AI to big data. I think we are here on the very edge of technology today. So, Monica, the floor is yours.
Great.
And
thank you, Angelo.
Yeah,
excellent. That's good to know. And thank you to the IRF team for the invitation to talk today. It's really lovely to be with you all, even if it's just virtually and not in person. So I'm IRAP's Global Innovation Manager, as Angelo introduced me, and I wanted to talk to you today about our AIRAP initiative. But before I do, I just wanted to touch a little bit on the conference theme, which is charting pathways to sustainable mobility. Road crashes have an extraordinary human toll on a daily basis, and this equates to an economic cost of around $6 billion per day. If that figure sounds a bit sort of out there or unrealistic, it actually, in per person terms, averages out to around 60,000 US dollars per person and per life. So that's counting for either a fatality or a lifelong injury. And this cost is being paid for by somebody. It's being paid for by families through loss of income. It's being paid for by our health and hospital system. It's being paid for by lost productivity from employers. It's being paid right across every economy around the world. And so I just wanted to bring back back to the concept of sustainability. It's not just about environmental sustainability, which is incredibly important, but it's also about social sustainability and economic sustainability. And so why is safety critical? The challenges are very real. We've got increased urbanization. Over half of the world's population now live in a city of some sort. Population is on the rise in many places, particularly in cities. You've got increased motorization and sort of these growth of high mobility roads. Speeds and motorization, ownership of vehicles is steadily increasing in many parts of the world. But you've also got this sort of need for better urban transport and a real shift in recent years to more light mobility modes as well. The picture you can see there actually runs straight through my neighborhood. I live in a city of 18 million people in Guangzhou in China. And this is a reality that I have to face in my daily life every day. And so some of the issues come from the fact that safety is dealt with in quite an ad hoc way, if at all, during the road planning phase, during investment decisions, during design, right through to construction and maintenance. And the evidence of this ad hoc approach is in so often we end up with roads that just totally lack sufficient facilities and safe facilities for other road users, pedestrians. And the evidence is in this stubbornly high rate of fatalities and serious injuries we see around the world. So we really do need to start thinking about safety as really being central to all of the systems and processes we use to manage and build and maintain our road systems. So what's IRAP? I think many of you have probably heard of us, but I'll give a quick snapshot for those who haven't. So we are a charity. We've been around for about 20 years, and we have a vision for a world free of high-risk roads. We have a star rating system and road models that provide proactive ways to manage safety across road networks. So our star rating system, you can see a map of Portugal here. Black is for 1 star, so they're dangerous sections of roads. We go right up to green, which are 5 star, which are the safest roads. And we do that for the 4 different road user types. So it's pedestrians, it's bicyclists, it's motorcyclists, and it's vehicle occupants. And so it's a really, it's a very good approach to make sure that when a road is being designed or when a road is being built or or whatever stage it is, those that are doing that are also made conscious of the needs of other road user types and aren't tempted to just ignore the fact that pedestrians might be using this road as well, and the road actually needs to be safe for them as well. So IRAP's tools, our crash risk mapping, our star rating systems, and our fatality and serious injury estimation tools have now been used in over 100 countries around the world, and we've assessed over 1 million kilometres of roads, and this has informed over $75 billion worth of investment to date. We've got partners all around the world, and we've also informed many of the road safety targets, including the second decade of action, which aims to reduce fatalities and serious injuries by half, and the UN road safety targets, which require that all new roads are 3-star or better by 2030, as well as roads where 75% of travel are happening are 3-star or better. But the challenge really now is, how do we do this on the scale needed to achieve these targets? And that's where our AIRAP initiative comes in. So AIRAP is pretty much about harnessing the emerging and the existing data that is around in order to make road assessments and road safety much quicker to do, it's cheaper and it's more effective. And so the sorts of data we're looking for is so mapping and navigation data, data from vehicles, crash data, road user data, and so on. The real objective here is to enable access to data. Data often exists in Europe. It's very fortunate that there's quite a bit of data around, but actually putting this into the hands of road authorities and enabling that access in order to scale up those activities, it's just, there's so many barriers and there's so many challenges. And so it's really about reducing those barriers and challenges. And to do this, we've essentially aiming to do two things. One is an accreditation scheme, which takes data that might be out there and puts it into a format that is easily used and can be readily plugged into either road asset management systems or just for road assessments or for other purposes. And then the second element is a data platform. So this is really a platform, a global platform, if you like, that aims to connect those that have data to those that need the data. And doing this has lots of potential. So we get the data standardization and the validation, which is really lacking in the data space at the moment. We provide a portal for that exchange of the data, but it also unlocks all of these other aspects and the potential. So this is where star ratings and safety assessments can be very routine parts of road asset management systems. It's around being able to scan large road networks, particularly in cities, and prioritize those areas that are unsafe and focus in on them. It's informing things like traffic modeling. So we really start to make sure that safety is really embedded in those systems and processes. So this is the IRAP vision, and we're somewhere over on the left side of the screen with being able to put together single and connected attributes. And we are not doing this ourselves. IRAP is the enabler in this. We are working with organizations right across the world that have this data and are converting it into this standard format to enable these things to happen. So once we get single and connected attributes, it enables simple road safety KPIs. We have the data platform, and this starts to enable accessible and large scale star ratings assessments and risk mapping to happen. As we move along and get groups of critical attributes and then eventually all attributes, it really enables those things to then be built into the asset management systems, like I was saying, and starts making safety assessments much more routine and seamless. Eventually, we are moving towards the space where star ratings and safety management will be fully integrated into those systems, and that allows for investment optimization and things like application into insurance systems, and that in itself will also open the potential for this social impact investment. And eventually we will move across as the data availability catches up to sort of dynamic real-time star ratings, where this will be informing things like consumer choice about people choosing where to walk or where to cycle or where to drive based on safety data, not just travel times and other decision points we currently have. And also has a potential of informing vehicle connectivity, so it can be influencing connected and autonomous vehicle speeds and driver feedback in real time. So that's the overall picture. There's a few things to note though. This process won't be linear and it won't necessarily be even around the world as well. A lot of this relies on the data environments and ecosystems that currently exist. But that's not to say that anything here is not possible. In fact, we're doing projects at the moment which all touch on almost every single aspect shown here. So the potential is very real and we're working towards it as an organization, and hopefully it will really reduce the barriers to data and fulfill the potential of it as well. Thank you.
Thank you very much, Monica. Really big things are happening with the IRAP scheme, and congratulate you for that. My question is, as we are moving towards this dynamic real-time stars rating, does this mean that hopefully in the future some static thresholds of today, for example, the upper speed limit of a highway, which is only irrelevant and it's a static stopper for some stars, would this maybe be replaced by a more dynamic and safety-related data, more integrated than just, okay, if this is your speed limit, something would happen? Do you foresee that?
Absolutely. I think the connection through to intelligent transport management systems is a very clear one. I think already some of those systems are being able to be adjusted based on road conditions and even weather conditions at the time. But I think being able to understand that in terms of a star rating, it's very clear when certain conditions change, when speeds increase, that star rating will change because our models are incredibly sensitive to traffic speeds. And that's where you really want to be being able to manage these things in real time and having a good effect of that. Yes.
Excellent. That's really good news. And we are all with you. We are also members to try to achieve this goal. If there are no other specific comments or questions, I think in the interest of time, we could move to the next presentation. And please look at what AIRAP is doing, excellent work. We move to Rick Nuyttens, the Senior Manager of Regulatory Affairs for the EMEA region. She's working with the 3M Transportation Safety Division. She's going to present us today critical issues in researching sustainable mobility, ADAS, and infrastructure synergy. Basically, this is ISAT related issues. Yes, Rick, the floor is yours.
Thank you, Angelos. I see that host has blocked my camera, so I...
Oh. I don't know why, Rick. I think...
Yeah, somebody doesn't like me.
Yes,
okay, thank
you.
Thank you. I have the clock in front of me and it's just 12 o'clock. So I know exactly what my 10 minutes are going to be. Let me share my presentation. I don't know if you can see it.
Yes, we can.
Okay, yes. So yeah, I was glad to see already several presentations on physical infrastructure and how technology is helping to assess the quality of road infrastructure. And my presentation will also move a little bit into that to see the relationship between physical road infrastructure and driver assistance, which is a hot topic at the European Commission today. Introducing 3M is not always easy. So this slide, I think you can see it at the presentation. Our president, Dan Chen, already elaborated on it as well. We are a big company relying a lot on innovation and trying to bring new products on the market every day. Future of mobility, I think it was mentioned already several times. Intelligent cars will help us to see things pretty soon, and already today also they will bring additional hands. And then talking about artificial intelligence and decision making, they will bring an additional brain to our service as well. So pretty soon, and I think this is the objective of many companies as well, is that we can then, as a passenger, we can use our brain for something else beside driving. But we're not there yet. The relationship, driver assistance and infrastructure has been mentioned already a couple of times, and more studies are also showing the importance of road markings, traffic signs in relationship to these driver assistance. The European Commission has put it in their big objectives on Europe on the move, and this third mobility package in Europe, which will is there to come, because I think next year we will see the first implementations already. The general safety regulation will make lane keeping systems, intelligent speed adaptation, adaptive cruise control, a whole range of driver assistance will become mandatory in the next generations of vehicles. And by 2024, we will see that every vehicle will have to have it. Studies have shown that there is a good relationship between good road quality and these driver assistance. So the objective to reduce accidents and save lives is possible. Of course, the debate on what roles and responsibilities is another discussion, which is sometimes frustrating. What is the role of the authority? What is the role of the car company? And of course, the driver for the moment is still in control. From 3M, we have tried to bring a little piece to the puzzle, a little solution, as more and more studies also indicate that driver assistance, road markings and rain don't match together. So the glass beads, which make road markings visible when they get wet, they are no longer able to return the light. So there is technology there that will help to make these road markings visible when it rains. So you just blend in other refractive index beads that compensate for the confusion, or let's say the light, the direction of the light that is disturbed by the water layer. The test that I wanted to share in the next minutes is one of the challenges that you have as a company in innovation, is that you can't go on the road immediately with new technology. So you are either limited to the laboratory, or you have to downscale the tests in order to validate the material that you have. We did not exactly want to look at the impact on driver assistance. We just wanted to see how different types of beads and different types of road markings could influence the picture, the clarity of the picture that then would be analyzed by the algorithm in the ADAS system. So we worked together with Fedicom, which is a renowned institute in France and based in Versailles. So they looked at several markings that had the whole range of performance, from being visible with having the beads that should be visible during the rain, and all the way to a black marking that is used to cover existing markets in work zones, so to make sure that these markings are not visible. So we wanted to make sure that these markings, that also this black marking did not create any false positives. So the study was really done to identify these markings clearly by the vehicle, And even technology was used, which is not available in the car today, to make sure that the sensor would not be confused and really look at the marking itself. Here, the picture on the right, you can see that with all the data fusion, that the marking was, if visible, was really part of the picture. So we looked at the contrast, or Vericam looked at the contrast from the luminance of the marking compared to the luminance of the road surface beside the markings. So here we used only asphalt. So if the measurements would have been done on concrete, the contrast ratings would, or the contrast would have been totally different. We also looked at visible, how it compared to the human eye. And you could see that during the day, also here, the brightness of the marking plays a big role. A yellow is a little bit more difficult to see. And also if the sun is in a glaring position, that sometimes you get totally the opposite effect, that some markings which would not be visible suddenly become visible as well, just because of the mirror effect of the sunlight. During the night and rain, here again we saw differences. Here the reflectivity plays a big role. And of course, when the marking gets wet, some of them disappeared. And in some cases, we also observed, this was not planned, but this was a benefit, that this road furniture, which is often used in construction work zones, the reflection of this road furniture could be very disturbing and make the road markings even more difficult to see, also to the human eye, but also then to the camera. The way we collected data is, of course, you compare human vision to machine vision, and here a camera is looking at pixels and is then looking at the brightness and the color of these pixels, and then the algorithm has to be able to decipher the object. Is it a road marking or is it not? The way we collected the data, as you can see, we measured contrast, but then the column to the right is also showing the confidence. How much data points did we collect? Did we get 100% of the data points that we wanted to collect? And in some cases, you could see that the visibility of the road marking or the weather situation would not allow us to collect a lot of data. And this is also quite important. Some of the data, the contrast was quite easy to collect, but in some cases we collected, or the sensor obtained much less data than we expected. That means that also the sensor was not able to collect all the data. So here you can see that the weather had really an impact on some of the, or the rain really had an impact on the collection of the data. And some markings were only visible, let's say, 20% of the time, where other markings would be visible 90% of the time. The overall conclusion is that during the day, you could see that the whiteness plays a big role, and the marking that did not have any beads was, of course, the most white, and you could see a slight benefit of having most of the white pigments at the surface not covered by beads, and even the camera picked up this slight difference and gave it a slightly better contrast rating. But the overall conclusion is really that it's very difficult to get a high contrast in daytime. You see the bigger conferences at night, when then suddenly you have a very dark background and the contrast is much easier to measure. And also here you can see that some of the markings had difficulties to be visible in wet or in rain conditions. Only the markings that had the special beads provided enough contrast to be picked up by the sensor. Another thing to mention is that as we measured only 15 meters in front of the vehicle, there is also an impact by diffuse illumination by the headlamps. The further you look in the distance, the more the impact is really defined by the beads and the ability of the beads to return the light back to the vehicle. We also looked at Lidar. Lidar showed a very similar profile as light itself. Road markings that are very good for visible light also seem to be very good for Lidar. The only difference with Lidar is that the Lidar sends out its own near infrared light. So the sunlight doesn't make any difference. You always have type of nighttime conditions in a Lidar environment. There is no difference between day and night for a Lidar. It always depends on the light that the Lidar sensor is sending out. So overall, we can make a conclusion that for daytime, the visibility of the road marking is very important. It's really the standard 1436 is capable of helping the authorities in defining this daytime brightness. Also, the norm, the European norm 1436 is capable of helping to specify road markings that are visible both to LiDAR and both to the traditional video cameras. And of course, if you look at the wet reflective properties, also here the European norm with the RR properties and the way to test it is really available to make sure that that you can specify road markings that have the capability to be visible during the night at rain. You just so the specifications can be put. Of course, the relationship to the background is very important. So the more details of the studies are available. I just did not want to go too deep in the study today. Thank you, Angelo. Back to you.
Thank you very much, Rick. Excellent presentation and indeed a very good benchmarking. We can see what we have to do and to solve versus automated driving in the future from the infrastructure side. And I think also you pointed out which sensor where and how we could or we should fuse those. There is one question for you, so I will read it out from the audience. Have you tried to check the reflexivity index of the markings when there are road studs? If so, what was the result?
No, we did not use road studs. The information I have about the road studs is that the surface is really too small to be picked up by sensors. So you really need a bigger line and surface for the sensor in order to figure out a picture. These reflectors are very good for human, but not so much for machine vision.
Very good. Thank you very much, Rick, for again, once more, for the excellent and detailed presentation. In the interest of time, we move to the last presentation by Nikolaus Stieldorf. Nikolaus is the Global Business Developer Manager at SWARCO, and he's going to talk to us about moving from silos to digital smart mobility.
Perfect. Thank you very much.
Nikolaus.
Oh, sorry for interrupting.
Yes,
Go
no
ahead.
problem. Floor is yours.
Perfect. So you should all, in theory at least, see my screen right now.
Now we do. Now we do.
Perfect. Here we are. Alrighty. So thank you very much, and that I can wrap up the session today with moving from silos to digital and smart mobility. What I tried to make sure when we now talk about this topic is that it's much less any sort of product presentation, but much more an insight into what we learned from our market. So what we saw, and then I'll quickly give you guys an outline, our customer needs are drastically changing, specifically in the world of mobility management, and SWARCO, as well as the remaining industry, obviously is here to provide solutions to that. So how do I make those statements? We as SWARCO, together with all of our partners, have initiated last year a global process of really interviewing, and right now I just took a screenshot a few days ago of over 450 let's say critical stakeholders, which really means largely cities, which means, for example, consultants, planners, which means partners, to overall get an idea which direction is our world moving in the world of mobility. And that, to me, the most important question here was, in order to make sure that we provide real solutions to problems, what are your top 5 problem statements? And there we spent quite some time in trying to analyze that data and into consolidating the data and making it analyzable. And so today, in today's session, I picked out 6 of the top or the 6 top problem statements that we saw globally from a city perspective that we need to challenge to move into the next world of a smart and digital world of mobility, and then give you guys an idea how we believe as SWARCO and how our industry overall believes that we can provide answers to these problem statements. As before, also, please feel free to shoot your questions in the chat, and we'll then handle them right after. So the first one that came up, and that's obviously we've heard now a couple of times today, that the topic around smart mobility, connected mobility, smart city. But overall, in most of the cities that you look at today, if you look at their vision statement and you ask them overall where you want to get to, they say we want to find ways how to get into a world of a smart city, of becoming a smarter city, a more connected city. And when we then dig deeper and say, what, if that's the problem, if that's the vision, what's really your problem? Then the main answer we received was this. They said, we have this massive patchwork of subsystems that are all partially connected, maybe not connected, but really our infrastructure, we now have 10, 12, 50 different independent systems running, and we're anything but smart or connected. So what does that really, or when we now take a step further, analyzing that. So today's most cities operate a patchwork of independent systems which largely act in an isolated manner. We all know that. We all know that a traffic management system might actually be independent of an adaptive system, might actually be independent of a parking guidance system, of a journey time system, and so on. You name all these different aspects that we see in mobility. A lot of times these are completely siloed subsystems. A lot, first of all, due to the lack of standards, but also because simply those were all procured in maybe different operations or different projects, but different departments. So what do we obviously need? A paradigm shift towards holistic mobility management is urgently needed. So if I not only want to make sure that I have different siloed systems that tackle the world of, let's say, vehicle traffic, but I really want to talk about smart mobility overall, with multi-mobility, with different modals to use for my last and first mile, with integrating public transport and new modes of transportation, I obviously need to move away from such a setup. So therefore, we see a critical need, and cities brought it up to us, to really work towards mobility management platforms. And how we tackle that as SWARCO, we have a platform that we now worked over 4 years in, found own companies for all of that, is on our end, a mobility management platform called My City. And in My City, we have all these different subsystems. We brought them together on a single platform where a customer can choose, I only want to use this solution or that solution, or bring them all together. But not only can you bring them all together on a platform, as you see on the right side, but also you have in the middle let's say, a strategy manager, a machine that allows you to create certain if-then rules, where you can roll out different use cases by connecting all these different subsystems. All right, let's get to the next one. Then when we talk to cities again, problem statement, another one was, by having this patchwork, we also have this patchwork from a hardware software perspective. So this complex third-party management, we really don't know how to handle anymore the more it gets. We have 10 different vendors out there, or 100 different vendors in terms of hardware. They all have different interfaces, different integrations. We as a city cannot really operate that anymore. Constantly something breaks because somebody shoots an update in that sense. But if we now go back to that big vision of a smart, digital, and connected mobility world, any definition that we look up for smart and connected city, you see the common denominator in them is the capability to share and process data from different systems in an urban environment. So therefore, this problem statement is a critical one, and actually a blocker to realize their vision. So therefore, we then, when we dug a little deeper and said, but what does that really mean? What are the pain points, or what could companies provide? What could be the solutions that allow you to go a step further? And then we really saw it's two aspects. It's on the one hand that we now use the umbrella term, the technical interface management. So the shortage of skilled resources is stated as one of the top city problem statements. And I'm sure that most cities that are participating today can feel the exact same way, that they say, I have a few guys that are experts in IT and in traffic and in mobility, but it's far not enough to handle all these challenges that we have. Therefore, we really have to pick and choose. And when we talk about technical interface management, that really means highly skilled people that know how to work with all these APIs to maintain that stuff. So therefore, we see that shortage, how cities are able to, or if cities are able to do that. then cities understand that their knowledge and capacity can never satisfy the complex operations behind technically maintaining such tremendous amounts of interfaces. So if they're already challenged today, if we really want to move into again, a buzzword, but into a smart city environment where we share and process data from all ends, maybe not even only from mobility environments, but also across the mobility environments, this is something critical to be handled. So therefore, again, coming back to that aspect of mobility management platforms, cities start to choose, and we see that traction, choose to outsource the technical interface management and focus on strategic topics, meaning they say, rather than me procuring all these different subsystems and silos, and then me needing to manage all these integrations and making sure it works, I want a platform where also the vendor behind it makes sure that all these subsystems, so hardware components, sensors, integrations with other central systems are handled and maintained by that platform provider, and I have a single point of contact, or in a negative way, a single throat to choke for to tackle exactly this challenge. So that's the technical interface management. And then on the other hand, which was actually surprising to us, or at least we didn't have it on the radar big enough, but it now becomes more and more logical, is the topic of contractual interface management. So what do we mean with that? Digitalization has led to a heterogeneous field of business models. So let's all think of ourselves. We might pay X amount of euros or dollars or whatever per month for our video streaming service. There might be another application that I paid for in a one-off procurement, maybe some piece of hardware, maybe my office chair. There might be another one that says, every time you ping my API, I want X amount of cents, or I get charged by my cell provider X amount of euros per gigabyte that I use it. So all of these are different business models that cities are really struggling with. So to work with that heterogeneous setup. So public procurement regulations are largely focused on a traditional CapEx model. So largely focused on, I now have this grant, I now have this in my budget, I now need to one-time purchase that, but they really struggle with reoccurring and transactional pricing models. And more than anything, they struggle with that heterogeneous setup. So having 10 different business models that a city needs to be able to consume is a challenge for them. So cities will require, coming back to mobility management platforms, but overall to larger scale providers that serve as and I'm now using the term contractual aggregator, that integrate the variety of business models into a single contractual stream that cities can procure. So also maybe a challenge to us technology providers, even if we build a solution that technically, or something that technically becomes a solution to a problem that cities are facing, if they cannot consume it, we still don't allow them to enjoy that benefit or that value add, and therefore give that value add to the citizens of that city. So therefore, we really saw we need to work that better out. We need to really double down on our efforts also to make sure that we can provide and make sure a city can consume all of that by having a single contractual agreement with us. And we then work on all these different heterogeneous setups of business models with the subsystems to make sure they can really arrive at the city. Then another point, forefront of innovation over rigid customization. So I think probably 1 out of 10 cities that we talked to, they told us one of our main problem statements are rapid innovations that we really not, our processes also, that we're really not able to handle. So what we mean with that is, or what they meant with that in examples was, for example, mobility as a service started happening. They already thought that was fast and they didn't really know how to work with that. But then once e-scooters hit the road, they really said, we have no clue what to do. We spent millions to keep in our downtown nice and safe, or safe, nice and beautiful, friendly for tourism. And now all our pedestrian walks are littered with all these different modalities. We need to become quicker. We need to become faster. But obviously the procurement cycles and the management cycles in the public environment are slower with reason, because obviously it's tax money. So adoption rates in our industry are lagging behind and therefore fail to benefit from innovations and instead face disruptions. So when we take, I don't know, as an example, how fast cloud gets adopted in a government environment rather than compared to B2B or private consumer environments, obviously you see a massive latency on that end. But that obviously also means that a lot of these value adds that could be provided with such technologies all of a sudden become disruptors than big benefits. Then the exponential acceleration of innovation in the mobility space will further amplify such discrepancy. So there's very few, and I've been until September, I was in in California for 5 years, now in Berlin. And you see there, when you go to Silicon Valley, there's very few industries where so much venture capital flows in, and there's so much interest also from a private equity side of things, than mobility. So the more also there's boost from that end, the fast innovation and disruption will get. So this problem that we're just describing will just get more amplified.
Nico, sorry, could you please conclude, because we are
absolutely. I'll hurry here. So since cities, yada yada yada, emerging innovations. Maybe as a last point for 2 minutes, was a secure hosting over expensive in-house infrastructure. So what we learned from these cities is they have no clue how to handle all these cybersecurity threats. So here you see a statistic of the damage that has been done, or in millions actually, so amount of monetary damage cost. And we see that cities are not able to handle that. So also this is a portion where we see a big needs for cities, or big need on that end, that they start thinking, how can I outsource the portion of handling a safe IT infrastructure rather than doing that whole thing in-house. Alrighty, I would say that was it. I'll wrap it up from my end so that we don't break the time here.
Thank you very much.
Back to the questions.
Thank you very much, Nico. You presented us the big opportunity, smart city as a service in reality. And you presented us the My City tool, which I think is very promising. And certainly we are going to look further on it. And I presume many of our colleagues here. In the interest of time, we don't make a question, but clearly we ask everybody, and there are several comments on the chat, to come back to you directly.
Perfect.
With that, I think we managed to close the session practically on time, although we started with a quarter of delay. And I think here, Susanna, I did a good job without rushing. And it is my honor and my pleasure to leave the floor to my good friend and fellow countryman, the president of IRF, Bill Halkas, to wrap up the day and close. Bill, the floor is yours.